Hi everyone, welcome back to my number sense series. In this video and the next video, we are going to talk about decimals. So for those of you who don't know about decimals, and specifically their operations with multiplication and division, this video is going to be for you. Because number sense likes to not only use the tricks that we've already learned so far, but they like to add them with decimals. So for example, if you remember the multiplying by 25 trick, they like to do that, but then replace 25 with 0.25. So you have to do that trick and also think about it being a decimal. So today we're going to basically just get some practice and get some fluency with decimal operations. So first of all, I'm going to go over real quick how multiplication with decimals works, in case anyone doesn't know. So basically, the thought with decimals is that you should treat them as regular numbers, like basically get rid of the 0 point stuff, and then reintroduce the decimal place right after you are done with all the calculations. For example, 0.15 times 0.8, the idea is that you should do instead 15 times 8 first, which is 120, and then you should kind of recalculate where the decimal point should be in here. And how do you recalculate the decimal point? Well, here's what you do. When you convert this 0.15 to a 15, you should be like tracking how far you move the decimal place. For example, here you have to move it 2 places to the right. So think about like 2. And for 0.8, you have to move it 1 place to the right, plus 1. So you moved it 2 times here and 1 time here. So in total, you moved it like 3 times, because 1 plus 2 is 3. And then, so in the end, you should take that decimal point and then move it back to the left 3 times to kind of, make up for it. So like, it goes from here, here, here. So your answer is 0.120, or just 0.12. Now, the mathematical reason behind this is basically to do with fractions. As you know, decimals and fractions are pretty closely related. And so what we're actually doing here is we're expressing 0.15 as 0.15 over 1. Then we're multiplying the top and the bottom of the fraction by 100. And this gives us 15 over 100. We're doing something similar for 0.8 by turning it into 8 over 10. Now, when we do fraction multiplication on these, we can see that the numerators are exactly this 15 times 8, and the denominators are going to be 100 times 10. And note that 100 is 10 to the power of 2 because we moved the decimal place 2 times. And 10 is 10 to the power of 1 because we moved the decimal place once. So when we get our product, the answer is going to be 120 then over 1,000. And notice that this 1,000, comes from this 110, which comes from 2 and 1. And this 1,000 tells us to move the decimal dot back to the left 3 times, because 1 plus 2 equals 3. Hopefully that kind of made sense as an explanation of how decimal multiplication is derived from fractions. And now let's just get some practice in. So 0.7 times 0.99, once again, our idea is to simply ignore the decimals right now and just focus on multiplying the numbers and then reevaluate and then see where we have to move the decimal dot. So 7 times 99, how do we do that? 7 times 99, that's like, once again, it's like 7 times 100 minus 1. So it's like 700 minus 7, which is 693. But don't write down 693 as your final answer because we still have a decimal. And remember, when you have a whole number, the decimal point is going to be quote unquote like invisible right here. This is where it is. And now, how many places did we move the decimal point in order to ignore the 0 point things? We moved it 1 time over here, then 2 times, 3 times. So in total, we moved it 3 times. So we should move it back 3 times. So 1, 2, 3. And our final answer is 0.693. And now another sanity check you can do when you do decimal multiplication is if you know that you are multiplying 2 numbers that are both less than 1, your product should be less than the smallest number you are multiplying. For example, here, the smallest number we're multiplying is 0.7. And I know that I'm multiplying 2 numbers smaller than 1. So I should be multiplying 0.7 by a number that is also smaller than 1. When you multiply something by a number that's less than 1, that number gets smaller. So I should be able to look at my answer and say, yep, that's the smallest answer in the problem. That's the smallest number in the entire problem. And indeed it is. Of course, by just a little, because 0.99 is very close to 1. But the fact that it is less is, a pretty good sanity check. Now next, we're going to do 0.64 times 0.005. Once again, just ignore the dots for now and focus on doing the integer multiplication. So 64 times 5. There's a few ways you could do this. My preferred method is basically dividing this by 2 and multiplying it by 10. In other words, if you divide something by 2 and then multiply it by 10, that's just like multiplying by 5, right? You're multiplying by 10 over 2. So 64 over 2 is 32, times 10 is 320. Another way you can think about this as a bit of review is essentially giving a multiple of 2 to the 5. If you half one number and then you double the other number, overall your product is going to stay the same. So what we're doing is having the 64, making it 32, and we're doubling the 5, making it 10. So 32 and 10 will make 320. So then we have 320, and now let's think about it. How many times do we have to move the decimal place? Well, to make this equal to 64, we had to move the decimal 2 times. To make this equal to 5, we had to move it 1, 2, 3 times. 2 plus 3 is 5. So we should move the decimal dot back to the left 5 times. So we go 1, 2, 3, 4, 5. So our decimal place ends up being all the way over here, which means it should be 0, 0. So our answer is going to be 0.0032. And once again, sanity check. Is this less than the smallest number in this problem? Yes, because it's 32 is less than 50. So now they will also give you questions about square roots and cube roots and things like that. So we should definitely cover that. So how do square roots and cube roots work with decimals? Once again, the answer kind of boils down to what happens if you think about them as fractions. So let's do that. 7.84. As a fraction, what is that? Well, if we think about it as 7.84 over 1, when we multiply the numerator and the denominator of the number by 100, what we get is 784 over 100. Of course, if you have another method of converting this to a decimal, feel free to use that. So we're now taking the square root of 784 over 100. In case you didn't know how that works, taking the square root of a fraction, it's equal to taking the square root of the numerator over the square root of the denominator. So it's like this. And now, hopefully, we kind of just have to memorize this. So hopefully you have this memorized. The square root of 784 is 28. So it's going to be 28 over, what's the square root of 100? Of course, it's 10. So 28 over 10, we get 2.8. And so the way that you could think of this in context is, okay, I'm going to move my decimal place twice to the right to make it 784. Then I'm going to take the square root of 784, and then how many times do I have to move the decimal place to the left? Well, I moved it to the right twice, and when I take the square root, it gets halved, right? So it gets halved, so I should move it back only once. So 28, move that back, it's 2.8. And a sanity check you can do here is basically think about like what this is close to. Just kind of in your head, 7.84, okay, pretty close to like 4 or 9, right? The square root of 4 and the square root of 9 is 2 and 3, so my answer should be in between 2 and 3, and this is in between 2 and 3, so you know you did it right. Now, it's something very similar for cube roots. The cube root of 1.331. Now, some people will have memorized their cubes, and they can recognize this very easily. But in case you don't memorize your cubes, which, you know, that is pretty normal. I only memorize my cubes up to like 12. I'll just like really quick go over how the process for finding cube roots works. So first of all, we're going to have to find the cube root of 1331. What's the cube root of 1331? Well, we can do our cutting off digits thing. So let's cut off 3 digits because it's a cube root. And now we have just the cube root of 1. Well, of course, the cube root of 1 is just 1. And it's slightly greater than 1. So we know our answer should also be slightly greater than 10. So then we start thinking, okay, well, what's the last digit of our answer? Since we know that the last digit of 1331 is 1, then the last digit of our number should be also 1. So it's close to 10 and it ends with 1, so obviously it's 11. So how did this help? Well, the cube root of 1.331 is like the cube root, if you convert this to a fraction, of 1331 over 1000. And so this equals the cube root of 1331 over the cube root of 1000, which is going to just be equal to 11 over 10, or in other words, 1.1. And the way that you can think about this is basically get rid of the decimal point. So you have the cube root of 1331. What's that? Well, it's 11, of course, as we just proved. Then 11. Okay, well, how many decimal places should we move it back by? Originally, we moved it to the right by 1, 2, 3. And then when I take the cube root, I will divide that by 3. 3 over 3 is 1, so I'll move it back to the left once. 11, move it back to the left once, and you get 1.1. So hopefully that serves as a good introduction or recap on how decimal multiplication and square roots and cube roots work. Essentially, it boils down to how you express these as fractions, but you can definitely just remember this by doing the how many times should I move the decimal place thing. So hopefully that helps. Thank you guys for watching, and I'll see you in the next one.